For page 73, title it Solving Radical Equations. And so it says to solve a radical equation containing one square root, you have 4 different steps here. You're going to get the radical on one side of the equation by itself. Everything else will be on the opposite side, numbers and letters. And then number 2, you're going to eliminate the radical by raising each side to the reciprocal of the fractional exponent. Solve for whatever letter you're looking for, and then you're going to check your answer. So, for example 1, this would technically be a radical. We would have 2 times x minus 2 to the 2/3 equals 50. This would technically be the cube root of x minus 2 squared. So this is a radical equation. It just doesn't look like a form of a radical, but it is one. And so first thing we're going to do is divide both sides by 2. So that when you do that, this is your answer. And so now we're going to use step number 2. We're going to eliminate the radical by raising each side to the reciprocal of the fractional exponent, which in this case is 2/3. So I'm going to raise each side to the 3/2. Now, in this 3/2 right here, if you remember, when you have exponents raised to more exponents, you will multiply them. 2 times 3 is 6, 3 times 2 is 6, so you end up with 6 over 6, which is going to be just 1. So these cancel each other out, and you're left with just x minus 2. 25 to the 3/2 is the same thing as square root of 25 cubed. Instead of cubing the 25 first, we're going to take the square root and get 5. When you do that and cube it, you end up with 125. Now, you'll notice that I have a absolute value here. The reason being is with this 3/2 right here, technically there would be a square root here, and then this would be a 3 here. So you would have the square root of this stuff in red to the 3rd power. Because you're taking the square root of a term that has an x in it, you would technically have a plus or a minus symbol here. So you could put a plus or minus symbol, or you can replace it with an absolute value symbol. And it says you need absolute value when the denominator is even. So if ever you are raising each side to a fractional exponent, and you have an even exponent, even denominator on your exponent, you're going to put an absolute value there. Because as I said, that's really like a square root instead of a 3/2. Now, when you go to do this would be technically x minus 2 to the plus or minus negative 125. And we want to set that equal to each 125, the positive version and the negative version. So we have x minus 2 equals positive 125, and x minus 2 equals negative 125. So when you solve each of these, you'll get 127 and negative 123. You should plug that back in to make sure that it works. So for example, we'll do 127 minus 2, which is 125. We'll do to the 2/3 power, that's the cube root of 125 squared, so it'll be the cube root of 125 squared, so that becomes 5 squared, which is 25, and then times that by 2, you get 50. You can do the same thing with this one, and you'll end up with the same answer. For example 2, we have 2 parenthesis x plus 3 to the 3/2 power equals 54. We need to divide both sides by 2 first, make that a 27. Now, the reciprocal of 3/2 is going to be 2/3, so I'm going to raise each side to the 2/3 power. When you do that, this becomes 6 over 6 again, so we're left with just 1, and you'll make an x plus 3. The cube root of 27 squared is going to be 9, because that'll be 3 squared, which is 9. Now notice there is no absolute value this time. The reason being is this is really going to be a cube root here. So if you wanted, you could rewrite this with a radical and a cube root. Whenever you have a cube root, you don't put a plus or a minus, so we're just going to leave this as plain x plus 3. You'll solve, and you'll get x equals 6. So my note here says you do not put your absolute value if the denominator is odd. So when you go to raise each side by your fractional exponent, if your denominator is odd, you do not need the absolute value symbol. And then for example 3, we've got 2 cube root of 3x plus 3 equals x. So remember, we want to isolate the radical first. That means I need to get rid of this 3 and this 2. So I'll subtract 3 first, and then I'll divide both sides by 2. Oh, I didn't divide both sides by 2. You could divide both sides by 2. You'll get the same answer here. I went ahead and cubed both sides to get rid of this cube root symbol. If you want to divide both sides by 2, that's fine. You'll end up with the same answer as me. The only reason I didn't do it is because I would end up with x minus 3 over 2. and then I would have to cube that, and I would get x minus 3 cubed over 8. And you could work it from there, but it gets a fraction over here, so I just went ahead and kept it from having a fraction. So this becomes 8. The cube root of 3x all cubed is, these two guys will cancel, so you're just left with 3x. And then x minus 3 cubed unfortunately means I have to multiply x minus 3 times x minus 3 times x minus 3 because I need to solve for x right now. And I can't do that with this being a cube here. So now when I do that, I'm going to FOIL the first two. I get x squared minus 6x plus 9, and then I still have an x minus 3, so I'll FOIL again. Now that I have this, I have a polynomial. I've got a 24x over here on the left. I'll move it to the same side as everything else. And so now from here, we've got the 24x moved over here by subtraction, so that's where that 3x came from. You can factor by grouping at this point. These two terms have an x squared in common. These two terms have a 3. So when you take that out, you get x squared parenthesis x minus 9 plus 3 parenthesis x minus 9 equal to 0. You'll continue with your factor by grouping again because they both have an x minus 9 in common. So you're left with x minus 9 in parentheses times x squared plus 3. Set each of these equal to 0. You end up with x equals 9. And then x squared plus 3 equals 0. If you move the negative 3 to the other side, you get x squared equals negative 3. That doesn't work, so you scratch it out, and you're left with just simply the number 9. So if I come back up here and check to make sure I get that same answer, that it's correct, a 9 would go here for x, a 9 would go here. 9 times 3 is 27. The cube root of 27 is 3. Times that by 2 is 6, plus 3 is 9. 9 does equal to 9, so now I know I've got the right answer. And that's it for this page.